Okay, so today is all about functional programming. And with functional programming, making things simple is not the same as doing things the easy way. So it can take effort and design to make your program simple. And simplicity is an overall goal of functional programming. There's a there's a quote that says simplicity is a prerequisite for reliability. But why is that? Why are functions simple? Because sometimes being complex is the opposite of simple, and complexity can be our enemy. So if we have lots of just code that's just kind of like hanging out there, it can be hard to not only manage but read as other developers begin to work on these applications. So simplicity, we could say, is the ultimate sophistication process. And JavaScript lends itself well to functions. If something's not functional, would it be appropriate to call it dysfunctional? You don't always need an object hierarchy or to attach all functions to objects, which we'll be able to kind of take a look at today. So in functional code, the output value of a function depends only on the arguments that are inputted to the function. So calling a function, we could say f for function. In this case, if we call it twice with the same value, will produce the same result or output each time. Anyone think of some examples like that where given the same input, we'll always get the same output? No guesses? What if we had just a basic function that just accepted a number and then we log that number? So if we put in 2, should we expect 2 every time? Hopefully. If not, something would be really, really strange going on. Typically, this is kind of where the concept of like state management can come into play, because if we have other pieces of code that are relying on these variables, functions are not always what we call pure, in that they can actually modify other parts to them. So if you're not careful, these components and other variables can be changed without our awareness if we're not careful. So in the concept of immutability and referring to something as an immutable value, an immutable object is an object whose state cannot be modified after it is created. But mutable objects can be. So the two biggest cases here for us in JavaScript are strings and numbers. So let's actually take a look over on the whiteboard and see how that looks. When we refer to these data types as being immutable, we're not referring to the variables that we're storing these values into. We're referring to the actual values themselves. So declaring this name equal to Rick, even though we change, if we may update the name later on, it doesn't change the fact that we had this available to us what we mean by immutability, not being able to change the actual values. The concepts of declarative programming, it's a way of telling the machine what you would like to happen and allowing the machine to figure out how to do it. So this is moving away from the imperative style of programming that you might be accustomed to, which is more or less a way of telling the machine how to do something, and the result will be what you want to happen to it. So think of a traditional for loop. That could be considered more imperative because we are stating this is exactly how we want to run through our data set. We can describe to our function when we want it to break and if we need to break out of it, versus declarative styles such as for each, where the computer is going to literally run through each one regardless, and then it will figure everything out for us depending on the function that we pass into it. Stateless or pure functions don't depend on and they do not modify the states of variables out of its scope. So to be more clear on this, a pure function will always return the same result given the same parameters. Now the concept of first-class functions, functions that support passing functions as arguments to other functions or returning them as values from other functions. We've actually already seen this in our code, right? Where have we seen this in our code? Yeah, the concept of first-class functions, being able to pass in functions as arguments to other functions, and being able to use those values. Can you think of a case where we've actually implemented first-class functions? Mm-hmm. Yep. Sort is one, and even our toHTML we could call a first-class function because we're returning the value of that and putting it into another function to then append the result of that. So the append method is expecting our toHTML to return a value, even though toHTML is a method or a function all on its own. So that's the concept of first-class functions, treating functions just like any other data type and object or value. So we've highlighted the most important ones to understand for functional programming, at least for today. And we're going to walk through a few of these. Anyone had the chance to actually experiment with any of these array methods so far? If not, that's okay, because we're gonna walk through some of these actually right now. So the for each we should be somewhat familiar with. It will apply a function once per element, but note that it doesn't return a new array in this case. And when we talk about sum and every, we're not returning any actual data back, but what we are returning is a Boolean that we can then check to then conditionally modify other parts of our logic in our application. And then here's where we start to get into some methods that will actually transform a collection into a new array. So concat, filter, map, and reduce. Being able to transform a collection without actually modifying the original data set, which can be important in some cases. I'll leave this up there for just a little bit more. Everybody good on this slide? Okay. So we're going to open up our console. And let's start off. Let's start off with some basic arrays. So we're just declaring a literal array, and we're going to run for each on it. And again, Shift Enter if you want to create a new line in the console. So this is fairly straightforward. We're just declaring a literal array in this case. We haven't saved it anywhere. But we still have access to the for each method because it is an array, and that for each method accepts a function. And which part? On the last line? Oh, wait a second. I think I need to actually remove that one. There we go. Because we still want to be within the function. Great catch. Yep, so we're still within that function right here. And element is in this case is just going to be pointing to each element in the array. And we can run this, and we get exactly what we are expecting. We console log out each item in the array. So this is declarative. We're just stating for each one, this is what we want to do. We don't care how you loop through the array. We just want to perform some action once per element in the array. So far, so good here. Let's clear this out. And let's actually store an array to a variable. So we're going to create var numbers array and set that equal to a literal array with 5, 4, 3, 2, and 1 as our values. You take a look. We do have it. And now, with this new numbers array, we can call the sort method on it. And what the sort's going to do, if you don't pass anything into it, is it's going to literally run through each element and try to process it in order based on Unicode, which has some gotchas associated with that. So if we just run sort without any additional arguments, we see that it has put it in ascending order for us. But now, if we declare a new variable random nums, we're going to set that equal to 1, 10, 2, and 21. So we have a new array, 1, 10, 2, and 21. That's stored in the random nums variable. And let's call the sort method on this now and see what happens. Nothing. So what's actually happening here? Yeah, so this is a Unicode fail in that we're only looking at the first one. So this one actually comes before 2, and it's not looking at the full value in this case. And the same thing happens too in characters. So anything that's uppercase will actually come before anything that's lowercase. If you're doing just a simple sort method call like we are here. So let's actually make this sort work to our specification based on what we've actually seen in our code before. So we're gonna declare our random nums. We're gonna call sort, but this time sort will accept a function which accepts the a and b parameters. And we're going to return a minus b. So if this, for each one that we go through here, if we return a negative value, it's going to sort to a lower index. And I think this is actually a really good time to showcase the Python tutor in action. So let's go ahead and do that. We will copy our original random numbers collection.
How does that work? Sorry.
Oh, for the sort. In this case, to put it in ascending order, it's going to take the current element that it's on. It's going to subtract from it the next element. And if it's a negative value, then it's going to place that element before the other one. If it's greater than, it's going to do the opposite. And if it returns a 0, so if we have two numbers that are the same, it'll leave them in the same place. So it's essentially just checking to see if there's a -1 or greater value, if there's something that's greater than 0, or if there is an actual 0 that gets returned. And then based on that condition, it's going to adjust the elements for us. So to put something in ascending order, we would check for the negative value in this case. And in Python tutor, for our JavaScript, we'll copy these two pieces. And we're going to click the Visualize Execution button right here. Let me check my connection. Okay, so this is what we get back. Okay, so notice on the right-hand side here, underneath the frames column, we see our global context. And initially, the random numbers array is undefined. The red arrow off to the left here on the line numbers is indicating to us the line of code that's about to execute. So down here below this forward button, we can actually step through each statement at a time. So we can click this the first time, and now we see that our actual random numbers has been updated from undefined to the array that we have inputted on line 1. And then when we click forward again, now we're inside of the sort method. So we see the two values that we're comparing. We see A and B are equal to the first and second elements in the array, which have the values of 1 and 10. If we hit forward once more, now we get our return value, and it's a -9. And if we hit forward once more, we see that 1 and 10 are now in the same place because we had that negative number. Now A and B shift to the next two, so we start with 10 now for A and 2 for B. And if we click forward this time, our return value is positive. So what happens now is that it first moves 10 over to the right, but it hasn't updated the first one because now we need to check the value of the next element after that. So we actually start back at the beginning and compare 1 to 2, and we get a -1. So those remain where they are, and now watch our array. Now our array updates, and the numbers have shifted into place. And we move into the next A and B comparison for our last 2 elements, 10 and 21. We click forward, we have a -11. And so we remain now in ascending order since we got a negative number back here. This is a really, really useful tool if you need help kind of understanding what is actually going on with your JavaScript. So let's go back and just take a look at that one more time. So again, the random numbers array is initially undefined. Then we declare it. We have access to it. We step into our sort. We start comparing the first and second elements. If it's a negative number, that means we want to keep them in ascending order. So in this case, they will stay where they are. When we compare 10 and 2, this is where the actual sort is occurring in this case because we're getting a positive value. Therefore, we're going to shift 10 over into where 2 currently is. And now we need to check for 1. Since we've just had a shift, we need to actually check on that first value again to compare it with the new value that's going to be shifted in the case of 2. And we get a -1, so therefore it's going to remain in ascending order. Now we can compare the final two, 10 and 21. Was this pretty helpful in just kind of stepping through some of the code? The link is pythontutor.com/JavaScript. We'll step through a couple other ones as we demo out more code here. Okay, so back in the console, if we're looking at our random numbers array again, and we look at sort again, what do you think will occur if we try this? Don't hit enter, ask a partner. Talk about it with a partner for a second. What do you think of that?
I think it's going to return the sorted array descending.
Okay.
21, 10, 2, 1.
Okay, so what are our thoughts? David says it's going to go in descending order.
It could do that. It could do nothing,
Mm-hmm.
assuming all the numbers are positive, or it could.
Is that what you expected? Let's take a look at the random numbers array. So notice again that the sort method actually mutates the array. And if we run this same method again, well, now look what happens. What's it actually doing? Yeah, it's actually reversing the order in this case. So what we can do since there are helpful methods for us, we can actually call a reverse method to do that. But I wanted to show you what the sort was capable of doing as well. Any questions so far? Okay, let's create an array of names. So there's our array of names. Should be familiar with the push method. Returns the length of the array. And it modifies the array as well. So we've just added Brian to the end of this array collection. But what happens if we do this? What will the concat method do for us? We've discussed like concatenation right before with string values and variables, concatenating them together. So if we run the concat method on this original array, we see that Rick has been added to the end of the original array, or has it? If we look back at our original array, Rick is no longer in there. We don't have access to that array because we actually haven't saved it. It returned a new array, but we didn't do anything with that new array, so we've lost it essentially. So we could create a updated TA array and set that equal to the original TA array. And now, if we run concat and take a look at not the update app display, the updated TA array, now we see that the Rick value is on this new array. So this is actually really powerful in being able to transform a collection without modifying the original set. So again, all we did here is we defined a new variable with which to save the result of running this concat on the original array, and we save that information into the new variable. Any questions on this part? We saw the sum and every methods on the slide deck, so let's take a look at those next. Original TA.sum accepts a function with a parameter of the element, which we can call name in this case. And we want to check and see if there are any TAs with the name of Geo. So what should we expect this sum method to return to us?
You forgot to put the name in the expression.
Yep, thank you. We would expect error if we hadn't done that. So what should we expect as a result now? An array of Geo, true. Any false takers? Any undefined takers? True. Okay, now let's take a look at the original TA array. Okay, so it's nothing's been modified here. All we've done is literally just returned a Boolean value to do a check for us, which is helpful because this can apply some logic to us later on without actually needing to modify or do anything else with our data collection. Let's try this with the every method. So we're going to call original ta.every, which accepts a function that accepts an element, which we'll call name again. We're going to utilize type of to check to see if every element in our array is a string, because we're dealing with names, so we don't want any numbers. So we can run this function to help us out with that. And only if every single element passes this condition will we get a true value back. So if we were to push the number 2 into our original TA, and now we run the every method, we get false back because it returned false on just one of those elements, therefore the entire method will return false. Versus sum, it only takes one condition to either be true or false. But everything has to be the right condition for every to return true.
What's the return code? So you wrote original ta.push2 and
Return to 4, yes. So I just did it again, and now I returned to 5.
So that's giving your element position, is that correct? The length.
Yeah, push is a little confusing at first because it always returns the length, but it still actually modifies the array. So it's a little deceptive because if you're not looking for that, it's a little confusing. Has anyone tried to implement their own push method? It's actually a fun exercise that you do that has been done in 401 before, where you just kind of create your own method that accepts an array as an input, and it accepts any additional arguments of what you want to add to the array, and then you'll actually do that. So it's kind of neat to see how these methods are actually operating. It's a really good exercise. Okay, so those previous ones returned a Boolean value. So now let's actually start stepping into the ones that are a little bit more robust. So we'll start with filter, and we can begin with a new variable because filtered is actually going to return to us a new array. So we want to be able to pick up on this new array. And filter, just like sort and sum and every, accepts a function. And that function accepts an element among other parameters. If you've looked at some of the documentation, we'll call this name like we have been. And for this condition, we're going to only return names that are greater than a length of 3. And now we look at our new array. Sorry, Geo. Geo's no longer with us. And our numbers are gone too, actually, that we pushed. We pushed 2 numbers in there. But let's take a look at our original TA array. It has not been modified. So Geo's still in there, and each of our number 2s are still in there from that push method. Here's what that code looked like once more.
Mine returns an empty array.
Oh, really? We should take a look at that. Okay, let's utilize one from the Mozilla documentation. They set up an array called myfish, which I assume are just fish names. Angelfish, clownfish, mandarin, surgeon. Shift enter, and just so we can kind of keep that up for a moment, we're going to touch on splice here. So what's going to happen before hitting enter? Dylan? Yeah.
It's gonna cut off. It's gonna start at index 1 and cut off
One element. Okay. So arrays in JavaScript are 0-based index. Therefore, the 1 will point to clown and not angel. So we're going to start on that element, and the next number will say how many elements we want to remove starting there. So we get this return value of clown that's wrapped in an array, but let's take a look at myfish. And clown is indeed gone. So it returns the element within an array that was actually removed in this case. So splice will accept the starting position, the number of elements to remove, but also it can add. So if we start with the 1 position again and we specify 0, we're going to say, here's where we're starting. We're not going to remove anything. And in fact, we made a mistake because it was clown all along that we wanted to keep in there. It was always clown. We get back empty array, and we look at myfish, and hooray, clown has returned to our array. Any questions here? This is pretty neat, right? So we've called splice with -1. We get a return value of surgeon. And if we look at myfish, surgeon's gone. So we might have actually eliminated that extraneous fish name. Are there such fish? Is there? Okay, there is actually a surgeon fish. Okay,
I don't know about man. It's sturgeon.
Oh, sturgeon. Was I pronouncing that wrong? Oh, maybe it was just a typo. Okay, nice. Okay. All right, so let's take a look at our original TA array now. And help me remove those number values. So how can we remove those number values? Whoop. What's that?
Or you could just like not twice, but
So
you
start-
could also do 3,
Start with -1.
or you could just do that twice. Or
Could we put a
2 maybe.
could we put a 2 in here?
We could do 3-2.
Or a 3-2, right? But -1 will start at the end, guaranteed, and then we can
Would we want to start at -2 though? So it's this 2 that we want.
we get back 2. And look, our 2 is still there. So let's back up and actually, let's push that back in, okay? And then we're going to take a look. So now we're back where we started. And you were saying -2 because we're kind of going from left to right. So you're saying we can just, it'll by default just take everything off the end of it, and we get an array back with both 2 values. And now we look here, and now we have just our names. So one final piece here with this collection is we'll run map on it, which accepts a function, which accepts at least an element in this case. There are other parameters that we'll be looking at later on. And so within this map method, we're going to return our name and call 2 uppercase on that. But since it returns a new array, we need to store this into a new variable. We'll call that capTA. So we're transforming the original collection that were previously all lowercase values. And unlike the for each method, map will actually return to us a new array. Therefore, we can actually chain things off of map and actually add more functional methods to our pieces. So we can actually look at capTA now. We see that all of the named values have been converted to uppercase. And if we look at the original TA array, it remains unchanged based on the method. So very powerful. Questions so far? What about reduce? And what do those parameters that the function accepts what are those actually referring to? Did anyone get a chance to look at this from last night? Yeah, what are those? Could we say that they're similar to sort in that it accepts a function that accepts A and B values? Kind of those values that we were looking at with the Python tutor? We take a look at that first element and kind of look at the next one and then kind of move along. So calling reduce here it's actually going to squash these values into one collection. But let's look at the nums array, and we see that again it's unchanged, but it's able to return to us this new value right here. So this is a very basic use case for reduce, and that we can squash a set of values. And let's take a look at this in the Python tutor visualization. The reduce, we're going to take a look at that right now. Yeah. So here's our numbers. And here's our reduce method on numbers, which accepts a previous and current value. And we saw that when we ran it in the console, we got a value that was returned equal to 15. So let's actually visualize this. Okay, so initially nums is undefined. If we click forward, now we see that we have our array. It is defined, just like we entered it on line 1. Hit forward once more. We see our initial previous and current value, previous being 1, current being 2. So we're starting at our 0 index. So on the very first run through, the return value we get is 3 from adding 1 and 2, the previous and the current. Step forward again. Our previous, in this case, is not any element. It's actually become an accumulator of sorts. And in fact, this is where reduce becomes very powerful, in that our accumulator does not always have to be a number. And we're going to actually showcase how the accumulator can become an object, and it can even become an array. And we're going to whiteboard this part out, because this is where it's like really, really important to understand what reduce can truly do. And it's almost a misnomer of sorts, because reduce makes it sound like it only does one thing, when in fact it can actually do a variety of things that are extremely valuable to us as developers. So again, our previous value now from that last iteration is no longer referencing an element. It's referencing the accumulated value of the last iteration. So if we click forward now, our previous is 3. Our current is pointing to the index of 2, which has a value of 3. Our return value updates to 6. We step forward, and our previous is now 6. And our current value is 4 from index of 3. And we just kind of keep going along this same pattern of returning new values and setting those return values as the new value for previous. So previous will now be 10. And on the very final iteration of this, we add 10 to our last index of 4, which has a value of 5. And there we see our end return value of 15, and that's the end of the reduce method.
What happens if, say, there was a string thrown in there, and then would it start getting the string from that point on?
Woo, good catch. That would return an error probably, wouldn't it? Let me back it up just a little bit. Okay, so on the first run through, we get 3. Previous is now 3. Current is now Dylan. Return value, 3 Dylan. That's now our previous. Our current is 3. 3 Dylan 3. 3 Dylan 3 4. 3 Dylan 3 4 5. So just some implicit coercion going on between strings and number values. So far, so good here? Have we discussed implicit coercion in this class before? I do it every time, but I forget if I've done it already. Okay. Actually, I think JP has seen this. Or at least we've discussed it during project week when I was trolling the project teams in the 201 class. Does this look familiar? Have we discussed this part? So what's this going to return? Okay. How about this? Don't just take our word for it. One is less than 2 is less than 3. True. 3 is greater than 2 is greater than 1. False. So what's really happening here? We're talking about implicit coercion. Is 1 less than 2? True. Is true less than 3? True. So this gets converted to a number. In this case, a 1. What's that? JavaScript. That's the best answer I can give. Is it wants to be your friend. It wants to actually help you out and saying, you meant this is a 1. And this also points to another concept of truthy and falsy values of JavaScript. So 1 would be considered a truthy value, 0 would be considered a falsy value. The string false would be considered a truthy value, just as a heads up. So knowing what we know now, 3 is greater than 2. That is true. But now we're asking if true is greater than 1, or is 1 greater than 1. So we actually get a false back. So the very first line that we ran with 1 is less than 2 is less than 3 was true, but it was true because we were unaware of what was actually going on. It was true for the incorrect reasons.
So if you type in true right there, what will come up?
Oh, if we just type in true, we'll get true back. What about that? So the double bang operator will actually attempt to convert whatever value you immediately pass in after it. So this is a very nice shorthand way to check different properties. So we could try empty string and we get false. But then if we try value of Rick, we get true. So it's actually really, really neat. Do an empty object is actually true in JavaScript. Empty array, also true. It's a really, really good shorthand way of doing this. You can actually assign this to variables as well. So our nums array, true. Okay, how's our thumb meters so far? Has this been too much information? Just enough? Yeah, pretty good? Yeah, this part is a little extra. It's probably good to watch some like WAT videos. We watched one actually earlier yesterday. But just know that JavaScript has some weird parts that are kind of going on with it. But the use cases for those are a little extreme. You normally wouldn't see anything like what we just diagrammed on the whiteboard, but it's still good to know about that implicit coercion, as what we call it, the interpreter, the JavaScript interpreter, trying to help you out and not err out. So it's different from these other, you might have heard, statically or strongly typed languages that are expecting only very, very particular values. And when they don't get those particular values, they will throw an error. But JavaScript, for the most part, it's like, bring it on. I'll take whatever you give me, and we'll try to make it work. There's actually a really good cartoon, and I'll try and pull that up during break since we are at the top of the hour. So we'll take a 5-minute break, and we will finish up talking about what Reduce is truly capable of doing, and then we'll go into the lab prep for today. Let me see if I can Slack out the link for everyone. Assignment. Functional programming.
Lab or class lecture? Get it, but with a lecture.
In your My Fourth Labs. Yeah. One of the first things you'll notice is that we have kind of modularized some pre-existing components. So we've cleaned up some sections and actually incorporated them into their own files. So all the new article logic that we wrote out on Friday for the form building workshop, that's in its own JavaScript file now. And then for the code that we'll be utilizing today, we'll have that in an admin page .js file as well that we'll actually build out. But right now we're actually looking at the admin.html page, which is very similar. But we do have a new handlebars template. And the done comment says to set up a template for each row of the author stats section of the page, which is basically referring to this piece right here. So we're building out a template with that right there. So it's just a single line template that we're going to be using with handlebars to help us out. And then this is where we're actually going to append that information later on when we actually transform our data collection. But before we do that, we actually do have to actually transform the collection. So the assignment for today is going to be actually making and modifying our data set utilizing these methods, these array methods. So moving into article.js, if we look at load all, it says that the original for each code should be refactored using map, since what we are trying to accomplish is the transformation of one collection into another. So we're sorting based on date, and then we have this for each piece right here, but we can return a new array with map. So if we actually change this to map, we can actually keep most of this the same. Except in this case, since we're getting a new array back, we don't need any of this logic right here. And instead, we can just return that new article. And what map will do is it's going to build out that new array for us. But also, in order for this to work correctly, we have to actually set that array. And one change to take note of, the article.all variable that we had yesterday, I've replaced that with article.all_articles. So that way it's a little bit less confusing as to what that is. So we start off with this article.all_articles, and we set it equal to the data that we're getting, and we're sorting that data just like we have been. But now we can chain this map onto it because we're getting a new array back, which then we can build out with the new article. So each data set becomes this element. It takes over that element and it returns a new article based on that. Okay, below here it says that refactoring the article.fetchAll method, it now accepts a parameter that will execute once the loading of articles is done. We do this because we might want to call other view functions and not just the init index page or the render index page. So now instead of calling the article view explicitly, we can call whatever we pass in. And we can call this anything we like. Probably the most clearest parameter that we can provide to it would simply be called next function. So whatever that next function that we want to run once fetchAll has completed. You might see in some examples that next function be referenced as simply next. While next is concise, that can also be confusing because it's hard to tell when learning a new language if a particular word is a keyword, a reserved word, or if it's something that we're just utilizing here. But in the case with a function that we're creating, the parameter is a placeholder. So that could be anything. So we can pass into it this next function, and here's our stretch goal that's completed now, and it's a part of the starter code for today. And notice it's a little bit cleaner because we have actually dried out the code into this method called getAll. So getAll is doing the same things that we were doing in the code review, but now it's all a part of one function that we can call here on line 57, or we can call here on line 48, depending on the condition that's being met. But in any case, we still have to pass in next function. So that's part of the to-do here. And the next to do says to replace the following line with next function and invoke it. And then we have to do the same in 57 for article.getAll to pass in next function as well there, because in getAll, we have a to-do that says that we need to invoke the next function here. So notice how we're passing these values around. So we're kind of tying this back into functions as kind of first-class objects or higher-order functions that can accept other functions or return values from other functions. And that's all we're doing in this case, is we're just passing these other functions around, whatever those functions may be. So when we are in the index.html page, we want next function to become the render page method. For on the admin.html page, we want next function to become the rendering of the admin page. So we're keeping this very, very composable. And it's allowing us to dynamically run based on whatever function we pass in. So any function that we want to pass in here, we can actually invoke that once the function that it accepted completes. This to-do below says, chain together a map and reduce call to get a rough count of all words in all articles. So let's look at what's going on here. This article.numWordsAll is a method on the article object, something that we're already familiar with. But it's actually returning a new array at first, right? Because article.allArticles.map, well, we know what all articles is. That's our array after we get our data of all articles. And we know that map accepts a function. And the function that map accepts also accepts an element within that array collection. But what about this part right here? What's this return doing right here? Right. Since this article, again, is just a placeholder, but still that placeholder is referring to one article instance. And within that article instance, we can pick up on the body, which is right here. So notice the dot notation is just simply referring to whatever object we're currently on within our collection. And now what we're using here is just a regular expression that's picking up on, as Dylan said, the actual word count. And this is an increment operator in regular expressions, and then this is a global identifier to pick up on the entire collection. So everything within the body we're going to add within that body for all articles, and we're gonna get the length of that. There's actually a helpful website, I'll Slack this out, where you can actually test out regular expressions, and you can adjust them and modify them. So here's what we're actually using today. So this is actually really neat. You can actually hover over each character and it tells you what it's doing. So highlight over word, matches any word character, plus match one or more of the preceding ones. So there's our increment operator, and then the global search. So across the entire body. So once we have that value, notice we're still inside this map, but we've chained a reduce now to it because we're referencing the entire articles collection. So we're going to get a word count for each article. We're going to chain reduce to that, and we're going to return all of the words. You want to do one together? Done. Okay, next we need to chain together a map and a reduce call to produce an array of unique author names. So in this case, we're going to need to actually invoke the map method. And we're going to want to only pick up on the author names for each object and return just those names. And then we'll need to chain a reduce here after we map. And then this to-do says for our reduce that we'll chain here, since we're trying to return an array, we'll need to specify an accumulator type. So just like we did in our whiteboarding example, we'll need to actually specify that data type in our reduce. So those are the three parts to this all authors method. Our building out a map method. Within that map method, returning just the author names as an array, and then chaining the reduce to be able to pick up on just all of the authors. So at the end of this, we'll just literally have a set of unique author names. So it should be about a total of 5. So there will need to be some logic in that reduce to pick up only on unique author names. So think of your index. Think of your index tools, your index methods to be able to pick up on if something's in an array or not here. This last one is really fun. This one says transform each author element into an object with 2 properties. So this is also kind of similar in that we can return just about anything we want. In this case, we're going to return an object to be able to utilize for one particular piece. And those 2 properties are going to be the author's name and the number of words that they've written in here. So we're going to pick up, just like we showcased in this resulting admin.html page, we want to pick up on the author name and the total number of words that they've written across all of their matching articles. So this is our goal here in this last method. So notice we start off by returning this article.allAuthors function invocation. How are we able to do this? Should we be able to do that? Well, let's look at this all authors method. So this all authors method, what is the result going to be from this all authors method once we've actually completed it? So all authors should just give us back that array of 5 author names. Since we're getting that back as a return value, this is an array. The result of this function invocation is just an array of those unique author names. Therefore, we can call map on it, which we know accepts a function that accepts a parameter of whatever that element is. In this case, we've left the comment to say that A is a reference to an individual author, but we could also make this a little bit more explicit and call it author. And so within this map function now, we can return these properties in an object literal. So we can set a property of name equal to, and then you'll have to use some sort of notation to pick up on each of those pieces to be able to then build this out. And the number of words here, we've kind of built out some starter code to be able to assist in that. But we want to be able to add some logic to check for the matching authors across each article that we're running through. So give this a little bit of time, but know that if you get stuck, we're here to help, right? We don't want anyone to be stuck for too long. So do the best job that you can, because it gets a little complex in this last part, but it's completely doable. It's typically simpler than it may look at first. So keep that in mind. But then finally, we can run map to return the author's word count for each article's body. And you might use a similar regular expression to be able to complete that, just like we did above. And we can also, or then finally, we're going to need to reduce this down into one big number. If we look at the article view, we see a note at the top that says that we want to wrap the entire contents of this file in an IFI. So who's heard of an IFI before? It stands for Immediately Invoked Function Expression. You may also come across it when reading about closures and how we can actually limit the scope of particular functions. So anything within this IFI essentially is private to the global context until we actually explicitly attach something to the window namespace. So everything inside here will be considered private to us and to the global context. And then if we walk down towards the bottom here, note the to-do to be able to pass in the proper function to fetch all. Notice this module.article view equal to article view. And then notice we pass in window. Well, window is just our global context. So we're specifying the context in which to attach a particular method. So this is giving us greater control on what's actually getting exposed to the global namespace. So if we have, in this case, anything that's not an article view object will not actually get exposed to the window. So if we created any sort of just variable that otherwise would be global, if it's in the contents of this IFI or this closure, it's not going to be released out into the wild, so to speak. So let's look back up at the top here. Module is just our placeholder for whatever context we want to attach these variables to in the end. So when we actually invoke this IFI, window takes place of module. So just note that. And we're doing this again to reduce the amount of variables in the global namespace. Right now, a lot of functionality is already attached to the article view object, but later on we will be introducing helper methods to be able to assist us in our application that we don't necessarily need to actually expose to the window. Therefore, we can just have them help us out within our closure, and that's it. We won't have them actually attached to the global namespace. Actually, let's do one more. Let's complete this one. Insert the proper function here. What do you think we should call here? What do we want to do after we get all the data? It's right in front of us, yes. We can render the index page. So look at that. And we don't have to invoke it here. Because if we go back to our article.js file and we scroll back up to fetch all, once we've passed everything in here and we're done, it will get invoked for us once we complete these other to-dos. So that's where this next function gets replaced. Next function actually becomes that article view dot render index page. All right, so the final piece left here is we have this admin page.js that's blank. So we need to actually build this out. So this is going to look really familiar. What we're doing here is we're essentially building out the logic to append all of the new data that we are gathering or generating from that transformation of original data. So this one's picking up on the total number of articles. And this is picking up on all of the words across all articles. And then finally, we want to call fetch all. But what will the difference be in this case in terms of the actual method we want to run? So there's going to be a method now that replaces our next function parameter that will get invoked when fetch all completes. I think you got it. It's literally the method we just wrote out. Okay. So other than passing in these next function calls and replacing these other pieces, the primary task is going to be able to use the functional programming concepts that we learned today to then get the data that we want back. Any questions? Anyone need to see any other code or talk about any other piece of code?
I have a general question.
Yep.
So you've written this function in this file, but we're also looking at the file. Is that like good practice?
In this,
It doesn't really lend itself to this being like a library of functions.
yeah, in this case, we're offering a little bit of control. Now we are calling it immediately. The difference in our case here is that we only load it when we actually hit the admin page. So if we look at our initial index page, we actually don't load that file in at all. But once we get here, we will. Any other questions? Okay. We'll break for lunch and we'll get right into it. We have posted the pairs for labs. I've also created a sheet for whiteboarding that we'll do on Thursday. So I have an actual schedule out. It'll be about 15 minutes per person. So nothing big. We're just gonna run through a few examples just to get everybody comfortable with actually drawing out on the whiteboard. So it'll be a really good example for everyone. So that'll occur Thursday afternoon. Just as a heads up, and I'll send that out. I'll send that out today. Yes. Save. Yep. Any blue dots? I don't think we have any blue dots. Okay. So I'll save this and we'll break for lunch.